Today's topic is rational versus irrational numbers. It's going to get more in detail as we move forward in our math career, I would say. So in order to come back, this is a good video you can always revisit, because you'll notice a lot of math teachers use terms, oh, it's rational or irrational, and we often forget what makes it a rational versus an irrational number. So what is rational? Plain and simple, a rational number is basically anything that can be expressed as a ratio of two integers. In simple terms, if you can write it as a fraction. So any number that you can take and rewrite as a fraction is rational. Well, what is a rational that can be written as a fraction? Clearly a fraction or a mixed number. Even improper fractions are fine. Okay. Integers, positive or negative numbers. Those can all be written as a fraction. I can put them over 1. Okay. Whole numbers are integers as well. Now this is important to understand, a terminating decimal. If you look at these decimals, a terminating decimal is one that ends. It does not go on, it doesn't repeat. It's your typical decimals you work with, 0.5, 0.6789. As long as it's ending, it's terminating, I can make that one a fraction. Perfect roots, whether it's a square root or a cube root, those are rational. Because if you took the square root of 25, it's 5. That's now an integer. You take the cube root of 8, it's 2. That's now an integer. So if it's a perfect root, those are rational. Finally, my last rational that you guys are dealing with is a repeating decimal. Now, I don't make that a fraction the same way we make terminating. When we do terminating decimals, we put it over 10, 100, 1,000. When I make a repeating decimal a fraction, it's going to go over 9 or 99 or 999. That's another video that we will get to. But know that you can take a repeating decimal and make it a fraction. So if that's what a rational number is, what is an irrational number? I say irrational so that you're understanding the I. Some people say irrational, which is fine as well, but I emphasize that I, okay? So basically, an irrational number is any number that cannot be written as a fraction. I cannot change it into a fraction. What is that? Well, a non-repeating and non-terminating decimal. It has to be in the same. They both have to be that. Your most famous example is pi. We use 3.14, but if you were to type it in the calculator, or you know by now, I would hope, that pi is a number that goes on forever and it never repeats. So it's non-repeating and non-terminating. Look at the other decimal there. Nothing repeats there, okay? Granted, there is a dot, dot, dot. That means it's not terminating. That means it's still going on, okay? So there's some symbols to start looking for. Another irrational number is a non-perfect square root. So like the square root of 3. I can't find that without a calculator. Square root of 10. Again, can't find it without a calculator. And if you did take the square root, it's not a whole number. Okay, what happens when you take that square root, if you want to pick up a calculator really quick, the square root of 3, so you know, is a non-repeating, non-terminating decimal. There is nothing times itself that will give you 3. Okay? Okay, so let's take a look how we could see this. Here's a table. All we're doing is classifying rational versus irrational. If I look at 3 1/2, well, I can change that into a fraction, a ratio of 2 integers, because I can make it 7/2. Therefore, it is rational. So now I have the square root of 5. Well, off the top of my head, I don't know of any number out there that you can multiply by itself to give you 5. So it's a non-perfect root, therefore it's irrational. Now, it's important to understand what those 3 dots at the end of a decimal mean. That means that number is going to keep repeating. So I'm going to have 3 go on forever. It's not going to terminate. But I can make that a fraction by putting 3 over 9. So it is in fact rational. Last but not least, 4.75. Well, that's a decimal. It terminates. It's rational. And I hope, based off our notes and the example on the previous slide, everyone was able to mark pi as irrational. You'll start realizing if there's anything out there that has pi in it, if it's 2 pi, if it's 6 pi, if it's 3 pi plus pi, that is an irrational number, no matter what. Multiplying something by pi keeps it irrational. Okay? So, let's take a look at this. We're going to draw a circle around all rational numbers and a square around all irrational. So, here's my advice. Pause the video now and try these on your own. Okay, let's see how you did. Well, notice it's a decimal, the 5 is repeating, and the dot, so that is rational. Again, this is actually a repeating decimal because it's 2, 3, 2, 3. Those numbers are going to repeat. It's okay to have a repeating that way. Obviously, if it's a fraction, it's rational. That's basically the whole definition we're going off of. So this one might have thrown some people. But if I took the square root of 16, the square root of 16 is 4. So you really have 4 divided by 2, which is 2. So sometimes there's going to be a little work we have to calculate. I've got a fraction. That you should go through these and just, if it's a fraction, circle it. If it's a fraction, it's a rational number. There's my decimal, 0.5. That's the same thing as 1/2. It's rational. Now, there are going to be some square roots you should just memorize, and 81 is one of them. Square root of 81, we all know, is 9. So therefore, it's rational. And now this, while it's a negative square root, the square root of 100, that's a perfect root. That's 10. So this answer would be negative 10. And we can have negatives that are rational numbers. Okay? So a lot of you might be saying, well, Ms. Sintov, there's the dot, dot, dot. You're right, but look at the numbers after your decimal point. It's 1, 2, 9, 3. None of those repeated in the process. That dot, dot, dot is telling you that's going to go on, but nothing's going to repeat. So you got to be careful with your lingering dots that you look at the actual numbers before them. If nothing repeats then, like in this case, it's irrational. Here's that example I just said on the last slide. If you've got pi and you're multiplying by pi, it's irrational. There's no way that it will change into a rational number. Pi is irrational. Well, I've got another irrational number there. It's 1415 dot, dot, dot. So nothing repeated and it's going to go on forever. So these are examples of non-terminating, non-repeating decimals. And last but not least, we've got our square root of 30. There is nothing out there times itself that will give you 30. So that is just a basic. Feel free to subscribe below if you'd like some more rational and irrational videos or when something new is posted. It will help you with other concepts, and feel free to ask any questions in the comments below.